Hello and welcome. I'm your Professor Steve Wallen. This is homework help for Chapter 10. So let's get started, shall we? Let's see what we got over here. How much more or less output will the average American have next year if the 18 trillion GDP grows or contracts by? Okay, assume a population of 320. So let's look at our main variables here. We got 18 trillion. That's what we're looking at right now for the GDP for this year. 320 million people. Average American, so we're going to find out what it is per American on average. This is not how it's really distributed, obviously, but this is if we were to distribute it evenly. And how much more or less, okay? More or less. So we need to get that in there. So let's go ahead and let's pop this all in there. Let's go get a calculator out. Okay, 18 looks like that. Don't you feel special now? You know what 18 looks like. Right there, 3 zeros, 18,000. 3 more zeros. What's that? 18 million. 3 more, 18 billion. 3 more, 18 trillion. 18 trillion has 12 zeros. Okay, 12 zeros. Now, if we divided that between 320 million people, divide, right there's 320. Right there's 320,000. Right here is 320 million. Each person would get 56,250 if we were to split it up, okay? So therefore it's an average. Obviously we're all not getting that, okay? 2% increase. So a 2% increase is, if I times it by 1, it's gonna stay itself, right? But I need to times it by 1, and I need to add in a 2%. You just times it by 1.2, okay? That gives you 2%. Because 0.02 equals 2%. So all I do is add 0.02 onto 1, and I can just times that, and boom, I get the new number, okay? So there's 275, okay, or 250, sorry, times 1.02 equals 5735. That's our new number, but is that what they want? No, more or less. So I gotta minus the original. Minus 56250 equals 1,125. Let's put that in. 1,125. All right, that's the first one. Now for the second one, what do they want? 5%. We used 0.02 for the first one, and we know 0.2 equals 2%, then I can assume 5% is going to be what? 0.05, right? And then I got to add my 1 on there. So 1.05 is what I'll times it by. So this times it by itself, the 1, with an additional 0.05%. So let's go up here, put in our 56250, double check, looking good, times 1.05 equals 59,062.5. Is that what they're wanting though? No, more or less. So minus 56250 equals $2,812.5. So 2,800, let's see, 812.5. 812.5. There we go. Yes, 2 decimals are required. All right, moving on. What do we do about this one when it's negative a percent? Well, we've been adding onto 1 based on the percentage, right? So if it's negative, let's do black. If it's negative here, negative 1% is going to be negative 0.01. And if I add that to 1, okay, if I add this to 1, I'm going to end up with what? 0.99. So that's what I'm timesing it by then, okay? So I take my base, which is that, so I'm going to go back up here. 56250 times 0.99 equals, all right, but is that what it's looking for? Nope. All right, we got to minus the original. Minus 56250 negative. We end up with negative 562.5. That's what we end up with. Let's plug that in. Negative. Make sure to put your negative sign. 562.5. Did we do it right? Did we do it right? Let's find out. Check my work. Better be green. Good. We did it. Hallelujah. We're on to the next one. Let's move on. Next. Ooh. Now we're looking at the labor force. Remember, labor force includes people that are willing and able to work, and you're over the age of 16 and you're looking for work, okay? So, here we have our population. We can see it started out in year 1 at 310 million, went to 320, so we did grow overall in people. And that affected the labor force. Instead of 150 million, we now had 160 million people in the labor force, but unemployment went from 8.7 million to 9 million. So what does that mean? Well, let's take a look. What is the unemployment rate in each year? Unemployment rate's pretty simple. You're going to use this numbers, all right? And you're going to compare it to the number below it. So all I do is take 9 million. This is for this one right here. And I'm going to 9 million, 9M, divided by 160 million. That's it. That's all you have to do. So let's do this real quick. Clear this out. I'm gonna go 9 divided by 160, and we already assume it's in millions. Okay, so that's our percentage change. So we come over here and write that as, move the decimal to get your percentage, or to change the decimal into a percentage, I should say. So it's going to be 5.625%. Let's put that in. 5.62%. Okay. Oh, it actually goes out to a third spot. It goes out to a third spot. Put that 5 in there. Put the whole number in there just in case it wants you to be that specific. If it ever goes out that far, put it in there. All right, next one. Well, let's do year ones. Oh, sorry, this should be for year 2. Even make sure that if you do it out of order, you put them where they belong. So year 2 should be down here. 5.625%. Remember, it's a rate, so it's going to be in percentage points. Perfect. All right. And then let's go ahead and go up here. We'll clear out all this other stuff. Well, all right. Year 1, we're going to do 150 million, right? 150 million. And it's going to be 8.7 divided by that. So pop that into our calculator. Remember, why are we not using the population? Because we're only using the labor force versus unemployed, okay? That's how you figure out your unemployment rate. If you're not over 16, if you're not trying to work and able to work, then we're not putting you into this equation as far as the unemployment rate. So we go up here, And also it should be noted that even though you might be employed, you can be severely underemployed. Okay, that's definitely a possibility. This doesn't account for that, obviously. 0.7 divided by 150 equals, okay, 5.8%. 5.8%. Shift percent. There we go. All right. Let's see if we did it right so far. Moment of truth. Get used to always just checking your stuff. Makes it easier. We see green, that means we're good to go. So what do we notice here? Well, year one, we had a higher percentage that was unemployed. We had 5.8 versus 5.6. Even though in year two, we technically have more total unemployed people. Okay, between year one and year two, the number of unemployed persons, okay, well, the number of unemployed people increased, went from 8.7 to 9 million, but the rate, because we had an increased labor force here, actually decreased. Does that make sense for everyone? So, even though unemployment, the total number increased, went from 8.7 to 9 million, we had a lot more people here, so the rate actually went down. Okay? The number of unemployed persons, we just did that, so this should be easy. Number of unemployed persons increased. The unemployment rate decreased. So they want to really make sure you know what you did here, because it's the exact same thing. Check my work. All green. Perfect. All right, let's move on, shall we? Question 3. Ooh, tuition in the U.S. All right. So you got to pull some numbers out of here. Let's go number pulling. All right. College prices in the U.S. have again increased faster than the rate of inflation over and over and over again and over long decades. And so now we got extreme high tuition because it's been doing that for year after year after year. Tuition fees at a private college climbed to 3.7%. That's a big number. On average, this academic year, according to the report dated by College Board, for in-state residents, four-year public schools cost. So for in-state, for public schools, theirs rate 2.9%. All right, measured by the Personal Consumption Experience Index. Okay, overall prices, consumer 1.4% in that year. Okay, so they're saying our inflation was 1.4 that year. So nominal price increase, well, we can just straight up put on, let's see, academic year at private nonprofit. Okay, so this is where you have to make sure you're doing it for the right one. So this is private nonprofit. So that one would be that number right there. We're looking for four-year public schools. We'd be using that number right there. We'd be going down to that one. Okay, so we just straight up just put the number in. They give it to you in the article, 3.7. All right. However, what's the real price of tuition? Well, this is nominal. That is what inflation is. Inflation's that percentage of it, okay? And I say percentage meaning a total percent of it. So meaning if I have 3.7, I need a minus 1.4 from 3.7. So I go up to here. I take 3.7 because out of this 3.7, 1.4 of it's just inflation. So minus 1.4. So 2.3 is what's real increase in tuition, is 2.3 when adjusted for inflation. So let's see what we got. Clear out all that junk. You see green? We got green, everybody. We got green. That means we're good to go. So again, all you have to do, find which one they're looking for, and then you got to minus out that from the number, okay? You got to minus out the inflation, which in this case was 1.4, and it's a direct minus. Okay, you just straight out take, if it's 3.7, then you minus out 1.4, and that's what gave us the 2.3%. It's a straight up takeaway. All right, let's go to the next one. Number 4. Nominal GDP increased roughly 10 trillion in 2000 to 16 trillion in 2012. In the same period, prices rose on average roughly 30%. Okay, so we got some things we got to identify here. First, we're going from 10 trillion to what? 16 trillion. So 16 trillion, 10 trillion. Okay, that's what we started at. So those are significant. Okay. Also, we're seeing that there was a 30% rise. So when we get our percentage points, we're going to have to minus 30% out. We're going to have to minus 30% out of whatever we get to account for this inflation over here. Because if they're saying prices rose, that's another thing that just says inflation. So we're at the end, whenever we figure out here, we're going to have to minus 30% from it. All right, so let's go ahead. Let's do the math. So if I take 16 minus 10 equals what? 6 trillion, right? And we want to see the difference from the original. The original was 10 trillion. We divide that by 10 trillion. So first get the difference and then divide by the original amount. So difference, then divide by the original amount. Okay, let's see what we get. Boop. All right, here we go. 6 divided by 10 gives us 0.6. All right, so we got 0.6 so far. Let's go over here. We have 0.6. Now remember, we had this negative 30% we have to deal with. Negative 30%, saying right here, right, prices rose 30%, means we got to put that in here. So we go here, go minus 0.3, which is 0.3 is the same as 30%, equals 30% overall. Okay, so we ended up with here being a 60% increase, but then we had to minus out that 30%, and so that left us with just 30% overall. Let's put it in. 30%. No, not 305. 30%. All right, check my work. Did we do it? Did we get it? We got it. Good job, everybody. We did it. And get rid of all that. Last one. We're almost there. Last one. Ooh, we got a fancy chart. We might not need it, but you can use the chart if you want. All right. Using the table is what would the real value in 10 years of $100 you hid under your mattress in 2016 if the inflation rate is, and it gives you some options. Basically, what this question is wondering what's happening to your money if it's not growing over time. Because if there's inflation going on and you're just holding on to money, it's losing value. Okay? If it's 0% inflation, then you're lucky. Your money is the same as what it was when you hid it under your mattress. So if I had $100, and in 10 years, if there was 0% inflation, it would still be worth $100. However, if there's been 2% inflation every year, then my money is constantly going down. So if you look at this chart here, they're showing you, and they're doing it with thousands of dollars here, and then they have percents here in each of the columns. So let's say if I had $1,000 in 5 years, 2021, that $1,000 would only be worth $906 if we had 2% inflation every year. Okay, so this is just something that does a quick estimate for you on it. So we'll do this one with an estimate, okay? Which we can easily do because we're doing 100 and 100 you can associate with 1,000 pretty fast. So 2%, 10 years, okay? So we go 2%, 2016, be 2026, and if I did 1,000, it'd be $820. But because I'm only doing $100, I can take a zero off, and it's going to be 82 here, okay? So here we go, 82. All right. The other way you can do it is you can grab your handy dandy calculator, okay? Calculators here. They don't give you a chart like this. You can grab your calculator, and all you do is you can go 1.08. We're working on this one down here right now. And if it's for 10 years, all I do is compound it using this, using it because it's going to keep doing it by itself, and it's going to times by itself 10 times. That's going to give us a rate of 2.158. Wow. Okay. That is quite a big rate that we're losing with that. So yeah, it is a pretty big rate. However, we'd be looking to see the inverse of it. So I mean, we could go through, do the inverse. Quick method though, if they're giving you the chart, just look over here. It's 8%. 10 years, 463. Let's go into here, be 46.3. And that's the fastest way to do it. I'll just do the chart. Chart's fast. I mean, you can work it out in the calculator, because they're just going to show you how much you're going to be losing per year, basically. Because this is what it would increase by, and therefore yours would be the inverse of this. So let's see. Here's have to equal that. Yeah, I could teach you this method. It's going to be a while though. Just use the chart. It's going to be easier because these ones always do give you charts. Because I'm already giving you enough formulas. I don't want it to be too complicated. All right, there we go. This should all be correct though over here. And it's all correct. Perfect. There we go. That's everything. If you want me to one-on-one, I can go ahead and show you how to work it out using a calculator. But if they already have this showing you, I mean, it's a lot faster just to use their chart and reference value. All right. That should be everything. You guys all take care.